Over to you.
Thank you, Tuan, for the introductions. So I'm really excited today to be here with you today to talk a little bit about the automation of the identity security. Okay. Um, 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 I hope to give everyone the idea that automation should be one of the key parts for securing the identities management system. So we, the team in WMG, has done several work with threat modeling in the um, in the identity management system, and what we can say after that is the attack surface in IDM is really large and complex. Doing threat modeling manually is take a long time, so we think that there should be some automated approach that can accelerate the process. Automated red teaming has been used proactively in the general security system, and identities is one part of the system. So we think that it can be applied for the identity management. And the other thing is automated red teaming is empowered by the AI application, so it can give more accuracy, completeness, and efficiency for the IDM security. So in this work, we review the state of the art of the automated red teaming technique. We examine the benefit and limitations of applying automated red teaming in IDM, and we outline a framework which considers several strategies connected together for applying the automated red teaming in IDM, and we give a use case to demonstrate how the thing works in practice. So when we talk about identity management system, we talk about authentication, authorizations, access right for users, and many of the devices and online services. So it's very important. We also talk about the data, the user data, credential data stored in the database, and this it's a very highly complex system, and with diverse architectures, and have many ways of implementations. So so it's going to involve a large and complex attack surface, and vulnerable to a variety of cyber attacks. So the problem is there's currently lacks of effective automation approach to understand the securities in identity management system. I talk a little bit about the automated red teaming. So you can see several common activities, security activities in the system. So we have here the red team. The red team here is representing the attack agents, which can do several things to attack the network. And the blue team is defining size to try the defensive mechanisms. And there's the red teaming is similar to the penetration testing. Thank you. Yeah. Red teaming is similar to penetration testing, and cyber threat hunting is different. The main difference is using advanced attack techniques to get the most critical weakness of the system, while the other techniques is about checking the list of security vulnerabilities and see if the system can pass this. And we have here the cyber range, which is to simulate the real things, and we have the operation environments where contains the access to the system and also the working environments between them. So the automated part of red teaming is enabled by some tools, exploitation tools, and threat emulators, which can create the testing scenarios and repeat them rapidly. So we review the state of the art of automated red teaming techniques, and we found like 4 common techniques. The first one is attack graph, which is widely used, and it can represent the relationship between the assets, the vulnerabilities, and the attacker goals. So the attack plans can be represented by the path in the graph, and we can it's useful to predict the attacker behaviors, doing something like risk assessment and mitigation plan. The second approach is the framework, which is a structures approach to analyze the attacker goals and behavior systematically. And when the information is overloaded, a framework can help the analyst by doing things like filtering and visualize the knowledge. So the analyst can get to the point quicker. Compared to the attack graph, the framework is more flexible and can provide more comprehensive attack surface. The third approach is knowledge representations, which is extracts the knowledge automatically from multiple information sources, and the knowledge is normalized by language as a structured trace information expressions, also called sticks. The first one is automated planning, so it enables the self-learning capabilities, and it can generate a sophisticated trace through the AI techniques. So some of the common techniques are as a Markov decision-making process, the Bayesian inference game theory, or reinforcement learning. The application of automated red teaming in IDM's securities can provide several benefits. The first one is we can understand the vulnerability better, so it can cover a wide range of attacks and threat actors. We can know the relationship between the attacker and the assets. We can specify the interaction between the attackers and defenders, and so on. And it can also strengthening the security through threat emulation and training, so it can mimic the real-world operating environments. It can provide scenario for training the users to get better understanding of their system security, and it can avoid the risk of damaging the real working environment by the simulation. The other thing is it can provide the insights of the security posture, so the users know more about what is the risk, what is the cost, what is the trust reputation of the system, and can increase the speed and accuracy, so has a good plan for discovering the new attacks and recover. Other benefit is that it can recognize and overcome the hidden false assumption and biases of the security decision maker by training, by testing. Besides the benefits, there's also some challenges of the applying automated red teaming in IDM. So the first thing is the IDM has a broad test scopes, but we have very limited resource to integrate the scope into the automated tools. So the other thing is the realism of the test. So it's difficult to replicate the operating environments, which are influenced by many dynamic factors. For some case, like if the IDM using the blockchain is going to have some performance parameters that is difficult to replicate. The other thing is IDM can contain several sensitive personal data, which is the subject of the testing compliances and restrictions. And nowadays, the chance of IDM security is making more decentralized. So it puts security to the end user side, so it's making it more difficult to test the decentralized scenarios. And because some of the automated red teaming techniques is based on the artificial intelligence, based on the data training, so it's can also creating the new hidden biases for its model. And currently there's also missing tools to extract and enrich the knowledge about the IDM threats. So that is the challenges for the applying. So we come up with several strategies to apply automated red teaming in IDM. So this several strategies coming together. So the center of our our framework is we use Mitchell's ADT and CK, which is attack tactics, techniques, and common knowledge as an engine for the automation. Because this framework is can already do many things like getting the attacks profile, attack actions, getting the attack plan, and have some tools that enable the testing, automated testing for the attack plans. But this framework is about the general security, so it's not specific on identity. So that's why we need some these strategies to collect the data and extract and update the new knowledge, new identity security knowledge automatically and integrate into the Mitchell framework. So we have existing work which deal with us, which is the identity threat assessment and predictions framework from the University of Texas, where they can extract the information from media news and security reports. We also have automatic language processing tools like NLP, PDDL, and these tools can translate the security knowledge from the reports to the threat vocabularies like sticks, CAPEX, CV. Okay, so we can, the other strategy is to maintain and enhance the knowledge on the measures, so making it more toward the identity securities. We can also develop the applications as drive the application in the measures, the capabilities of measures, to making it more focused on the identities that's needed from the reality. And because the resources for automated red teaming is limited, so we can enhance this by building a community to share the best practice, knowledge-based system, and to enhance the available resources and accelerate the knowledge building. So I guess we don't have time to go to the use case, but is it?
I think we need to move on. Sorry, yeah, just because we have another speaker in this session.
Okay.
Thank you very much.
Thank you.
We should. You're going to be around all day, right?
Yeah.
So if people want to talk about this use case, would be maybe useful to catch in the break. We have a break after the next speaker. There's one question here. I think it's really nice. This turns out to be, if you're a computer scientist, you're into safety and liveness. So most of what you're talking about is sort of safety properties.
Yeah.
But liveness in ID systems is often a problem. So does your red teaming detect non-liveness, as a failure mode of a system or a vulnerability of a system? Is that part of one of your problems you might be looking for in the automated red teaming
Not
tools?
right now, but I think this can be considered in the future. Yeah.
So, I mean, effectively, if the ID system is not live, I can be denied access to something because it can't ID me. And this is actually a common failure mode. We heard from, I think it was Smile, which is a financial service outfit in Africa, that 5% of financial transactions fail in Africa because the internet has broken between various points. 5%, 1 in 20. That's really scary. So that's a liveness failure. But imagine, you were just trying to get your subsidized food from a shop from government food subsidy shop, and 1 in 20 times you don't because your ID lookup fails. But imagine that's not just because of reliability in the technology; it's actually because of attacks or other things. So you can imagine that being denial of service attack effectively.
Yeah. So the automated red teaming is really depend on the tools. So I think it's not there yet, but maybe it can develop in the futures. Yeah.
Great. Okay, there's a couple of other questions here, but maybe we can take those in the break or offline.
Yeah.
But there's some, they're all good questions. We're out of time now. So
Yeah.
But thanks again to Speaker.